Welcome back with another video on TryHackMe.com. This is Zahin Nazir and we are doing intro to Kubernetes. It is a part of the DevSecOps learning path and it comes under container security module. Okay, so we have covered already task 1 to task 3 here. As you can see, today we're gonna start with the task 4 and hopefully we'll cover next 3 tasks at least within next 30 minutes, and last 2 we'll cover in the next video. So let's get into it. I already started my attack box, as you can see. Let me open up the browser and terminal as well. So in the meanwhile, let's open up the task 4. So it is about the Kubernetes landscape. We had covered the Kubernetes 101, Kubernetes architecture, control plane, user plane, worker plane, and how they interact with each other. So let's see what we have on the Kubernetes landscape itself. The lay of the land. So we have just looked at Kubernetes architecture and how things work and are set up behind the scenes. Now it is time to show you the lay of the land. In other words, what as a DevSecOps engineer would you be interacting with daily? We will go through some of the most common concepts in the Kubernetes and break down what they are. So namespace came up before in the Docker container or the containerization part. Okay, into the containerization we come across namespaces, where namespaces can be used to isolate the processes within the kernel or the operating system. In the Kubernetes, namespaces are used to isolate groups of resources in single cluster. So it's also the isolating group of resources in a single cluster. For example, say you want to group resources associated with a particular component, or if you are using a cluster to host multiple tenants, to group resources by tenant, resources must be uniquely named within a namespace, but the same resource name can be used across various namespaces. Okay. So it's kind of like an object. Within the object, you could have similar name, for example, person, address, or whatnot, properties, right? But these properties can also live in another object, in another namespace, right? The object name could be different, okay? Maybe object 1 or object 2, getting it? So namespace basically will isolate and group together the resources. So if you know about, for example, tag will basically are used to mark some resources that these resources are part of some tag or some kind of group. So it's a similar concept here. Namespaces. Replica set. This is important to understand the replica set, because you will be interacting a lot with the replica set. As the same and the name suggests, the replica set in Kubernetes maintain a set of replica pods, can guarantee the availability of X number of identical pods. Identical pods are helpful when a workload needs to be distributed between multiple pods, and also for high availability. Replica sets usually are not defined directly, neither are pods for that matter, but are instead managed by a deployment, which bring us to our next concept. So the replica set comes under deployment itself. Okay, so what is the deployment? Deployments in the Kubernetes are used to define a desired state. Okay, so desired state could be, for example, in one deployment we need to have 10 pods running. Okay, so in order to meet that state, the replica set will create 10 replicas of the pods that you want to have. Once this desired state is defined, the deployment controller, one of the controller processes, changes the actual state of the desired state. Deployment provides declarative updates for pods and replica sets. In other words, as a user, you can define a deployment. Let's say, for example, test nginx deployment. In the definition, you can note that you want this deployment to have a replica set comprising 3 nginx pods. Once the deployment is defined, the replica set will create the pods in the background. Okay. But all of this will start from a deployment. Okay, so replica set comes under deployment. Okay, stateful sets. To understand what Kubernetes stateful sets are, you must first understand the difference between stateful and stateless apps, like REST or SOAP kind of things. Stateful apps store and record user data, allowing them to return to a particular state. For example, suppose you have an open session using an email application and read 3 emails, but your session is interrupted. In that case, you can reload this application and state will have saved, ensuring that these 3 emails are still read. Stateless application, however, have no knowledge of any previous user interaction, as it does not store user session data. Okay, it's all about session, what happened, where you are, and basically storing the previous state, so user can, resume the activity where he had stopped. But in the stateless, user session is not there. For example, think of using a search engine to ask a question. If that session were to be interrupted, you would start the process again by searching the question, not relying on any previous session data, unless you are logged into the Google search or something like that. But if you are not logged in, that means there is no session at all, and that means the services that you will use will be considered kind of stateless. Once you close your browser and come back again, if there is no history at all of your session, that means your session will be lost and will consider as stateless. But now everything, whatever you do on your computer, some kind of data is saved for audit purposes. Okay. For these stateless applications, search engine example deployment can be used to define manage pod replicas. Because of the application's stateless nature, replicas can be created with random pod names. When removed, a pod can be deleted at random. However, this is not the case for stateful application. Email example. Because stateful application needs to access and update the current state of the user session, imagine this current state is being stored in a database running across 3 pods, meaning the database is replicated 3 times. Now, that what happens when one of the database is updated? This would leave 2 of the databases out of the sync. This is where stateful set come in, and is why you would use the instead of deployment to manage stateful applications in the Kubernetes. Stateful sets enable stateful application to run on Kubernetes, but unlike pods in a deployment, they cannot be created in any order and will have a unique ID, which is persistent, and meaning if a pod fails, it will be brought back up and keep the ID. Okay, so if one pod is failed, once it is back, we'll use the same ID that the previous pod had, and with also the data as well. We'll mount the data to that or the folder or something to that part, so that it can revert back to the previous state and then sync up with the rest of the pods to make sure the data is updated. Associated with each pod, in other words, these pods are created from same specification but are not interchangeable. Stateful sets will have one pod that can read write to the database, because there would be absolute carnage and all sort of data inconsistencies if other pods could, referred to as the master pod. The other pods, referred to as slave pods, can only read and have their own replicas of the storage, which is continuously synchronized to ensure any changes made by the master nodes are reflected. So usually what happens is, as you can see in the diagram, we have stateful sets. So one of them will be primary and master, okay? And the write will happen on the master, and the rest of the replicas will take the data and update their data in a synchronous or maybe asynchronous manner, depending on the configuration and the database that you are using. So if there is any read query, either it can run on the primary or it can send the request to other replicas. Okay, so it could be like writing intensive task will be on the primary, but the read will be on the replicas there. Okay, so this way the load is balanced by using all other replicas in our stateful set. Okay, so services. We talked about the service before, that the service will consider as a load balancer. So in this case, the service is one. Whenever we call services in the context of Kubernetes, it does mean that the load balancer. To best understand services in Kubernetes, it's important to understand the problem they are solving. Kubernetes pod or a federal mean it will be destroyed, and temporary. Meaning they have a short lifespan and are spun up and destroyed regularly. Imagine now a connection needs to be made to these pods. This could be from within the cluster. Maybe a backend application is running in these pods, and a front end application needs to access them. Or perhaps the request is coming from a browser. These pods are running a web application. For this connection to happen, an API address is required. If the IP address is required, not the API. If IP addresses are tied to the pods, then these IP addresses would change frequently, causing all kinds of issues. Okay, so if you are accessing the service based upon the IP address, that means it's going to be an issue. We need to use our DNS or domain name or something, some URL. Okay, so regardless which pod is destroyed or which pod is spun up, we don't care. We will communicate on the URL. Services are used so that a single static IP address can be associated with the pod and its replicas. In other words, a service is placed in front of these pods and expose them. Acting as an access point, having this single access point allows for requests to load balance between the pod replicas. There are different types of services you can define: cluster IP, load balancer, node port, or external name. To learn more about these types and service in general, check out here. What is there? It is services networking. So you can click on it and follow along. We will just move on, okay? So here is our captain. The source of the traffic will depend on the type of the service. We have traffic, we have service, and service is then sending the request to pods depending upon the configuration that we have here. So it could be either cluster IP. The service could have its own IP rather than the URL, okay, or the external name. It could be used as a load balancer or node port or external name. Or combination of all of these. So cluster IP, load balancer, node port, or external name. Okay, so let's move on with the ingress. So if you are coming from a cloud background, you already know about the ingress or outgress. Okay. In the above section on Kubernetes services, we mentioned an example of an application which can be made accessible by using a service to expose the pods running this application. Let's call this service A. Imagine now that this web application has a new feature. This new feature requires its own application and so has its own set of pods which are being exposed by a separate service. Let's call this service B. Now let's say a user requests to access this new feature of the web application. There will need to be some kind of traffic routing in place to ensure this request gets directed to service B. That is where ingress comes in. Ingress acts as a single access point to the cluster, and meaning that all routing rules are in a single resource. So traffic will come to what you say. You can say the gateway, right? Traffic will come to the gateway. Now gateway will decide, okay, the request is requesting the service 1 or it is for service B, service A, or it is for service B. So depending upon the request, it will route the traffic accordingly. And now then service A or service B could be either doing the load balancing, or depending upon the configuration, it will send the traffic to related pods, okay, to make the system high available. Okay, let's move on. Now we have DevOps and versus DevSecOps in Kubernetes 8 or K-Nights. K-nights. So if you don't know about what I'm talking about, K-nights, just check my previous video. You will get to know what do we name here and what does K-nights mean. This task has shown you some of the Kubernetes resources that work together to make a cluster. By the way, if you are using, for example, Kubernetes OpenShift version, OpenShift Kubernetes, then they have a lot of other things that are built on top of the service and all other things. That mean they have, for example, created their own layer on top of the vanilla Kubernetes services. So it's nice if you learn before you use the technology, because you will have a clear set of clear context in which you can operate, and you will have a clear set of expectations. Okay, resources to work together to make a cluster. Next, we are going to discuss how we interact with this cluster to create these components. But before we do that, this would be a great moment to discuss the division of labor in the work of kites or Kubernetes. It's important to understand, especially when learning from a certain career path, the difference between DevOps and DevSecOps responsibilities. At a very high level, you can think of DevOps tasks as these associated with building a cluster, and DevSecOps tasks are those associated with securing a cluster, or both of them, because DevOps is a part of DevSecOps, right? There will be, of course, be some overlap depending on the company architecture or corporate setup. But generally, these tasks can be defined as one or the other. As this room serves as an introduction, it begins by showing you the building blocks of a Kubernetes cluster and how to interact with these resources. DevOps tasks, as this knowledge is fundamental or foundational, understanding these concepts will help you in later tasks when we discuss securing the cluster. DevSecOps task. That being said, as mentioned, the distinction is important, and especially for those pursuing a specific career path. So keep this in mind going forward. Sure, we'll keep this in mind. Which Kubernetes component exposes pods and serves as an access point? I think service. Awesome. Which Kubernetes component can guarantee the availability of X number of pods? Replica set. Awesome. What Kubernetes component is used to define a desired state? Deployment. Awesome. So we have completed task 4. Let's move on to task 5 here. But before I do that, let me take a sip of water here. Okay. So time to configure. Kubernetes configuration. Now that we have covered some of the key concepts used in Kubernetes, let's combine some of them and walk you through how this would be configured. The example we will use is a deployment, which controls a replica set, which manages pods exposed by a service. Okay, this is our captain here. He's trying to do something with his laptop, and traffic is going on to the service. Now, service will talk to the pods, but before the service can do anything, we are deploying our source code, and deployment will make sure that what is our desired state, and this desired state, based on this desired state, using a replica set, will achieve our desired state. Okay, and then pods will have containers, and these containers will have some kind of web service or some service which we are running, and this container could be Docker or some other distribution. Okay, so for us in this course, I think we are considering Docker runtime as a container, okay, inside the pods. To configure this setup, we would require 2 configuration files, one of the deployment and one for service. Before giving you an example of how each of these files work, let's go over some of the basics of the configuration in the Kubernetes that will be consistent across these two files and all configuration files for that matter. Okay, sure. Finally, we have some practical work to do. First, let's discuss the file format. Kubernetes configuration files are typically written in YAML, like all other systems as well. We saw this one in GitLab configuration, which we cover in the SAT and DAST kind of tools. Check these rooms. These are part of the playlist on my YouTube channel. They can also be made interchangeably using the JSON format, but as per the Kubernetes documentation, it is generally considered best practice to use YAML given its easy, human readable nature, and just gotta keep an eye on that indentation. So it's kind of JSON, but a better form of JSON. I mean, you can represent data with less attributes in YAML. Required fields. Next, let's discuss the 4 fields which must be present in each of the YAML files, breaking down what will need to be included in each one. So API version, the API version of the Kubernetes API. We talked about the Kubernetes API before. You are going to use to create this object. The API version you use will depend on the object being defined. A cheat sheet for that API version to use for which object can be found is here. Okay. Let's see what we have here. Okay, so this is the API version. So V1 apps extension. I think apps V1. You have beta versions as well. A lot of other things. As you can see, right now, we don't care about this. Let's move on. Find what kind of object you are going to create: deployment, service, or stateful set. Metadata. This will contain data that can be used to uniquely identify the object, including name and optional namespace. Spec. The desired state of the object for deployment. This might be 3 nginx ports. Configuring resources. Okay. Those are very basics of Kubernetes YAML configuration files. Let's consider those and look now at 2 files mentioned above. We are going to take a look at the service config file first. Okay, so maybe this is service config file. As when defining a deployment and service, it is generally best practice to first define the service before the backend deployment replica set. That it points to. This is because when Kubernetes starts a container, it creates an environment variable for each service that was running when a container started. Okay, here is what our example service YAML file looks like. So they are saying that create the load balancer configuration first before doing any deployment or replica set. Okay, so let's see. Okay, so because they will create the environment variables which could be used to create the replica set or configure replica set. So API version is V1, kind is service, metadata is name, which is example nginx service. Spec is selector, app nginx. Port is protocol will be TCP, port internal is 8080, target port is 80, and then the type is cluster IP here. So this is the service that we will create. Even the nginx is required to have a working load balancer. Okay, let's break that down. API version is set to V1, the version of the Kubernetes API best used for this simple service example, and the kind is set to service. For the metadata, we just call this service example nginx service. The spec is where it gets more interesting. Under selector, we have app nginx. This is going to be important going forward when we define our deployment configuration, as is the ports information. As we are essentially saying here, this service will look for apps with nginx label and will target port 80. Okay. So the selector is any app which is running on nginx. Okay, so this service will attach it itself to that nginx pod, which is targeting port 80. An important distinction to make here is between the port and target port fields. Target port is the port to which the service will send request, and the pods will be listening on. The port is the port of the service exposed on. Finally, the again, this is a little bit confusing. The target port is the port to which the service will send request. Okay, service will send request here, and the pods will be listening on. Okay, the port is the port the service is exposed on. So this is the port that service will expose on. I mean, from gateway to service, a gateway will interact with service on 8080 port, but the service itself will send the traffic to the pods on port 80. I hope this will make sense. Let me consider this here. So traffic from captain's laptop to service will come on 8080 port, but from service to pod itself, traffic will forward it to port 80. I hope this is clear now. Let's move on. Which is the default service type? Now let's take a look at the deployment YAML and define the backend which this service will point to. Okay, API version apps v1, as we see in the link that was mentioned before. Current deployment. Okay, metadata is the name of the deployment. Then we have specs. It will have at least replica as a 3. Selector is match labels app nginx. Template is metadata labels app nginx. Spec container name is nginx. Image that we will use is nginx latest. Port on which it will listen to the request is containerPort, and it is 80. So this is what we have here. The first thing you might notice is that inside the spec field, there is a nested field called template, which itself contains a metadata and spec field. To understand this, remember the image at the start of this task. We are defining a deployment which controls a replica set. Here, in the outer spec field, we'll tell Kubernetes we want 3 replicas. So the outer one is this one. We want 3 replicas. Identical pods in this replica set. This template field in the template that Kubernetes will use to create those pods. So the template is what will be used to create these pods. Okay. Create this pod and so require its own metadata field. So the pod can be identified and spec field so Kubernetes know what image to run and which port to listen on. Okay. So this is internal spec within the template itself. So this is the total template that will be used, and this spec basically is telling which image to use and which port it will be listening on. Note that the port defined here is the same as the one in the service YAML. Of course, here target port. So that means the service itself will listen on 8080, and once the request will come, it will forward it to pod on port 80. And in the deployment set, we are mentioning that our container will be listening on 80. So both of these ports should be the same. Otherwise, our service will not work right. This is because the service target port is 80 and needs to match, as well as this in the outer spec field. We can see we have also set the selector field to have a matching labels, which matches that we define in the selector field for the service YAML. So here, matching label selector and this selector should be same. So we know that in here, matching label here, app nginx and app nginx is the same. which matches that we define in the selector field for the service YAML. This is so the service is mapped to the correct pods. With these two config YAML files, we have defined a deployment that controls a replica set that manages 3 pods, all of which are exposed to a service, and it's all coming together. Awesome, awesome. I hope all of this makes sense by now. If not, it's okay. Once we'll do the practical itself, it will make more sense, I hope. These config files are used to define the desired state of the Kubernetes components. Kubernetes will constantly be checking this desired state against the current state of the cluster using the ST, one of the control plane processes mentioned in an earlier task. Kubernetes populates these configuration files with the current state and does this comparison. For example, if we have told Kubernetes we want 3 nginx pods running, and it detects in the state that there are only 2 running pods, it will begin the action to correct this. Okay. Awesome, awesome. In a config file, you have just declared that you want 4 nginx pod, in which one of the required fields has this been declared. Required fields. Spec. Yeah. The configuration file is for a deployment in which one of the required field is this declared. The configuration file is for a deployment. So this is kind here. I'm gonna put kind here. Awesome. The pods in this deployment will be exposed by a service. In the service configuration file, the target port was set to 80. What should you put in the container port? 80, of course. Otherwise, it will not work. Awesome. So we have completed task 5 as well. So once we come back, we'll go through the task 6, 7, and 8, hopefully. We already on 32 minutes past into the video. So thank you guys for joining me on this journey. So once we come back, we'll start the task 6. If you have any comments, please mention in the down comments below. And if you haven't subscribed, please subscribe, help us build this community and join me on this journey. And thank you for all the suggestions and feedback until now. And see you, and I will see you in the next video. Bye bye.